So when we ran that movie similarities script on the cluster, there were a few things we changed. We changed the format of the input file because that changed for the 1 million ratings data set. We changed how the context was set up so that we could override all of the settings for Spark Submit and actually run it properly on a cluster. But there was one other thing we did that I kind of glossed over. And if you go down to the main section here, you can see it here, this little thing here. We actually added this dot partition by new hash partitioner 100 to our movie pairs RDD here. And, well, what the heck's going on there? Well, it turns out that's actually a fairly important thing to know about partitioning when you're running large jobs on a cluster. So let's have a little chat about that, shall we? So let's talk about partitioning. Turns out Spark isn't always going to do exactly the right thing for you. So sometimes you need to give it a little bit of a hint of how to best distribute the data that you have. That's what partitioning is all about. So it turns out that our movie similarity script runs pretty efficiently on Scala. If you were on Python, though, it might struggle to keep up with it. And we actually have to do a little bit of tuning of the script to get it to run reliably. That's where partition by comes in. So for one thing, that self-join operation we did was pretty expensive. Spark can't necessarily partition that ideally on its own. And there's also a group by operation that's going to further take the results of all those movie pairs and group them all together at one point in the script. That also needs to be efficiently distributed. So by using the partition by operator on an RDD, we can say explicitly, I want you to take this operation and break it up into this many tasks. So remember, Spark actually breaks down your script, the DAG if you will, based on stages between where it needs to shuffle data, and each stage is broken up into individual tasks that are distributed to each node of your cluster, each executor that you have. So you want to make sure that you always have at least as many partitions as you have executors. That way it can split up the job efficiently. Now there are a certain list of commands you can do, operations on RDDs, that will benefit from partitioning, and here's the list. Join, cogroup, group with, join, blah, blah, blah. Group by key and reduce by key are very common, okay? So you want to make sure that things are properly partitioned before going in there. And another important point is that once you specify a partitioning on an RDD, that partitioning will be preserved in the result of that RDD operation too. So if I do a group by key on a partitioned RDD, the result that I get back will be partitioned in the same way. And that's an important optimization because remember, stages are broken up by the need to shuffle data. So if I have the same number of tasks in each step of my operations here, I don't need to shuffle between those two. So it can actually reduce the number of shuffles that you have to do in your script, and that's an important optimization. So anytime you can partition and preserve that partitioning through a chain of commands, that will help your script run even faster. So how to choose the right partition size? Well, it's a little bit of guesswork to be honest, but like I said, you basically want to make sure that you at least have as many partitions as you will have executors on your cluster. And you might not know ahead of time how big your cluster will be, so you just kind of have to make an educated guess sometimes. Now you don't want to have too many partitions because that can actually result in too much shuffling of the data if you have to split it up into too many different tasks that run in parallel. You know, distributed computing is not perfectly efficient. So more distribution, more parallelism isn't always better. There's usually a sweet spot to be found. But you want to have at least as many partitions as you have executors, otherwise you're going to have these executors and these resources on your cluster just sitting idle, and that wouldn't be good either. So make sure you have at least as many partitions as you have the capacity for executors on your cluster. 100 is usually a reasonable place to start if you don't want to think about it too much. You know, that's indicative of, you know, a reasonably sized cluster, and that will give you pretty good parallelism in most use cases. And that's what we did here. So if we go back and look at the actual code for our 1 million ratings movie similarity script, you can see that we have this movie pairs RDD that we're going to do a group by key operation on here. And group by key is one of those operations that benefits from partitioning. So to make sure that's well distributed, we're taking this unique joined ratings RDD, mapping it, and taking the result of that and partitioning it into 100 partitions. So the syntax here is partition by, and then you pass in a partitioner object, which we create. Hash partitioner is one you'll typically use, and 100 means I want 100 partitions. So pretty easy to use in Scala. And the resulting RDD will also have 100 partitions, and that will get filtered down into group by key, which will now have a nice partitioned RDD to deal with, and it can do that very efficiently and in a very quick distributed manner. And part of that is why that script was able to complete as quickly as it did. If you think about it, we crunched 1 million ratings and created similar movies for every movie in the entire database in just a few minutes on that cluster. It's pretty impressive, but tricks like this are how you achieve that sort of speed. All right, so in our next lecture, let's talk a little bit more about the specifics of running on a cluster and things to watch out for and kind of reiterate some of the best practices there.